You'll come across electrical stuff probably more often than a lot of these other things. So you have to know what you're dealing with. Anybody who uses electrical equipment needs to have an electrical program where they're checking the cords every day, especially if you're on a construction site. Why might you think I would say that? Why should you check the cords every day, especially on a construction site? Somebody in the back, give me an answer. Why do we need to check electric cords every day? Say again?
Wires can get like frayed or...
Exactly. Traffic can crunch a cord if it's not protected. You're exactly right. They get frayed, cut, stripped, plugs get torn apart and become electrical hazards. So you have to have a good safety program to include checking cords. That's another one of those unpleasant statistics that you come across when you look up data like this. One worker every day electrocuted. Why do we include falls in this category of injuries related to electrical stuff?
Shocking. Working at heights on utility poles, getting shocked off.
Yeah, exactly. Somebody get electric shocked, working on the ladder, a bucket crane, whatever, and get blown out of the thing or off the ladder. They fall 20 feet. It happens. And certainly you can get burned real easy by an electrical shock. Basic terms, you'll probably come across them again somewhere. If you were to get electrocuted, which is it that gets you, the voltage or the amperage? It's the amperage. That's what's going to get you. If you ever take a first aid course, this is part of the first aid training to recognize electrical shock. And see, it doesn't take a lot to mess with your heart. That's milliamps. Any of you guys, ladies, ever had a slot car set? Trains? Any of that sort of stuff? Y'all probably too young to remember that sort of stuff. But the current in those was higher than 75 milliamps, which could be a problem. How many of you know how to use an AED? One, two counting me. Anybody else know how to use an AED? I would suggest you learn. I've been involved in a resuscitation attempt one time when we used an AED. Shot the guy 3 times, he still died. But he was probably too far gone before we got a hold of him anyway. It's not a pleasant experience, and I wouldn't wish that on anybody. But AEDs have been shown to save people's lives. If you're a manager of a work crew somewhere on a construction site, wherever you are, in the movies, if you know how to use an AED, you might be able to save somebody's life. So, food for thought. You'll get a shock if you touch the wires. Basic thing. Example, somebody getting shocked when they grab the wrong wires, the business end of the bad wire. Here's an example of what you mentioned a while ago. That guy hits the 2 wires that he doesn't want to hit, then knock him off that ladder. He could probably die from a head injury instead of being electrocuted. You ever touched an electric cord, drop cord, and found it was really hot? Because probably somebody plugged that cord into an outlet or a terminal strip that was too small to handle that current. We have a big problem with those sorts of things on campus because a lot of older buildings don't have the electrical infrastructure where people can plug in item after item after item, so they use a terminal strip. Worst thing they can do because it overloads the circuit. Now we can get shot potential or fire hazard potential because it's trying to carry too much current in too small a wire. If it doesn't trip the circuit breaker, it might cause a fire. Have y'all ever seen any of this, right? Too many outlets plugged into something? I've got a slew of dormitory room pictures where people have done this with, you name it, all sorts of charging devices, TVs, music players of various types, you know, laptops, you name it, overloading circuits, which creates nothing but a problem. If you're outside, you get to working on a construction site, something like that, be sure you have GFCIs on your outlets, especially if you're outside. Because if it rains, you're just inviting trouble if you don't have a protected circuit. And y'all seen these before, right? Mainly in restrooms, kitchens, bathrooms. If we had more time, we could talk about how we could wire those things to be effective in a long string like on the bench over here. But I found this in the inspections I've done to be pretty consistent. I can almost always find a grounding hazard of some sort. Either that pin on the bottom of the 3-plug extension cord is gone. Sometimes I find in the outlet on the wall, if I find one. Sometimes it's disappeared, or somebody has used an adapter. You see the little gray things that you plug into the wall and put a 3-cord plug into? In the business, it's called a cheater plug. It discontinues the ground. You put somebody at risk of electrocution using those things. Here's what I'm talking about the pin disappearing. A lot of times that happens if I'm sitting right here. I try to pull that cord out of the wall from over yonder, bang. Pin stays in the wall. Now we've got a double problem because I got to figure out how to take that pin out. Means I got to find the breaker, cut the breaker off so I don't get fried in the process. If you're using hand tools, power tools, and the cord has a 2-prong outlet, check the label. If it doesn't say double insulated, don't use the tool because something's wrong. Somebody has rewired that thinking they're doing a favor to whoever's going to be using it, when actually they set them up for an accident, electrocution of some sort. If something says high voltage, don't mess with it. That's pretty simple, unless you know what you're doing. See, all these switch boxes right here, all these panel boxes have to be intact to be safe. If one of them, if you walked in here, for instance, for a class and found the cover off that box, what would be your first thing to do? What might you think would be the first thing you should do? If you're here with Dr. Hilton, you go tell him, hey, that cover's off. Then everything stops until we figure out why it's off and what we do to get it fixed. We don't want anybody electrocuted. They have to turn a circuit on. Compliance people all over the country probably cite that type of thing 4 or 5 times every time they do a compliance visit for OSHA or whatever organization does that sort of inspection. Because all that does is invite trouble. Somebody who might be walking by, working in the area, unguarded wires. So be aware of those sorts of things. I keep kind of going back to construction sites because a lot of these show up very obviously in construction sites when you're using drop cords. Anybody see a problem with this drop cord right here? The one on the floor. I could trip over it, and in the process of my tripping over it, what else could I do? Tear it up, pull it out of the wall over there, leave the pin in, all sorts of mean, nasty things. Construction sites, you got all sorts of vehicular traffic, as you mentioned a while ago. You get wires crushed, cut, torn, so you have to be aware of those sorts of things to check your cords to make sure they're protected. Generally speaking, a drop cord can be used for 90 days and no more. It's called temporary wiring, unless it's at Christmas time. And say, why at Christmas? Well, that was something built into the OSHA standard to allow a little bit more time at Christmas for decorations, okay? But for other purposes, 90 days is the max. Now, if somebody raised their hand and said, what's to keep me from unplugging it, counting to 5 or 10, and plugging it back in and start the 90 days over again? I'll say nothing in the world. As far as the letter of the code goes. Is that really being safe? No, not really. You're still extending the use of that drop cord beyond what it's supposed to be used. If y'all walked in the lab here one afternoon for a class and Dr. Hilton said, we need to make sure that this is working, go see if the breaker's on. And you pull the cover and the breaker's flipped. What should your next response be? Dr. Hilton, the breaker's flipped. Or should you flip the breaker and say, okay, I flipped the breaker back on. If you flip that breaker back on, what could happen around the corner that you're not aware of? Some of you worked on that circuit, couldn't you? I actually had that happen when I was doing an inspection in a company outside Charlotte, North Carolina a few years ago. They made Christmas tree ornaments. The guys were working on a motor in a small room about the size of that room right over there. Had run a drop cord out the door, around the corner, and dead-ended it into a circuit panel around the corner. I said, what's going on here? And he had left. Fletcher had left. So we had to get everybody together and have a little talk about leaving exposed parts energized and walking away from it. Okay, but if somebody had flipped the breaker on, had that been cut off, me or whoever's in that room might have had an unpleasant experience. Everybody follow? Everybody tracking what I'm saying about that? So that's why we have things called lockout tagout programs to keep those sorts of things from happening.